Hey guys, this video is going to go over the next 20 examples which are in the interval notation packet. This packet is sort of a connection between lesson 1, which was relations and functions and identifying whether or not a relation is a function, and lesson 2, which is being able to identify the domain and range of a function. If you want to write domain and range in a more advanced algebraic way, in a pre-calculus kind of way, in a college level sort of way, you're really going to need to know how to use interval notation. So to get us a little bit more comfortable with interval notation while also reviewing some concepts from Algebra 1, we have this packet, okay? So for all examples provided, follow the indicated directions, show all steps of your work, circle your final answer. You may use any available space in your booklet for scratch work. The use of a calculator is not permitted. You really shouldn't really need it for any of these examples. You should be fine, okay? The following tables are provided for your use as you continue to practice. That doesn't mean for your use on a test or a quiz. So here we have some samples of interval notation, and at the bottom of the page we actually also have a little bit more specific examples. So I hope you take the time to read this, and this is all stuff we discussed in class, and I'm not going to read it to you, okay? Not story time. So here we have problem number 1. We have an absolute value equation. Solve the given equation, show all steps. You must do these things, okay? Show how you would check your answers. Just like the absolute value inequality, we want to isolate the absolute value first. This is a throwback to an Algebra 1 idea here. So here we're going to have 9r minus 2 in the absolute value bars. Take away 9 is equal to 20. Showing all my work, I'm going to add 9. That gives me the absolute value. I don't know why I started all in the middle. I really shouldn't have done that. 9r minus 2. I'm going to make my absolute values pretty long and maybe a little darker to separate them. Equals 29. What does this mean? Think. Whatever's in here, it could equal 29. 9r minus 2 can equal 29. But whatever's inside there, 9r minus 2, well, that could also equal negative 29. It can equal either one because you're going to take the absolute value anyway. So your work looks like this. The absolute value bar stays in certain steps. If you notice, I don't just get rid of it, okay? This work comes from the fact that you have an absolute value. So you're going to have two different equations to solve. I'm going to add 2. 9r is 31. I'm going to divide by 9. R equals 31 over 9. That's one answer. You leave it like that. Then I'm going to add 2 again. 9r is equal to negative 27. Divide by 9. R is equal to negative 3. 2 answers. There they are. Check your answer. You would go back to the original. I'm not going to do that right now, but that's what you would do, okay? Next, we have compound inequalities. We have an or state in the middle. It could be this or it can be that. The word or is very important in your number line and your interval notation. Solve the given compound inequality. Show all work, graph, then write the final solution set using interval notation. So here I have 9 minus 3p is less than or equal to negative 18. And also have 2p minus 10 is less than negative 26. I'm going to subtract 9 from both sides. 3p is less than or equal to negative 27. Divide by 3. Now, if I divide, do I flip the sign? No, you only flip when you multiply or divide by negative. So p is greater than or equal to negative 9, or, now this one, add 10. 2p, I don't know what I'm writing, sorry. 2p is less than negative 16. Divide by 2. P is less than negative 8. So it can be this or that. Very important. Here is the negative 9. Here is the negative 8. Greater than or equal to negative 9. Here's negative 9. I can be greater than or equal to negative 9. Or I can be less than negative 8. Or if this said and, it would only be the space in the middle. However, it says or, so there's a few trick questions in here. If it says or, my entire number line is really colored in, okay? Everything. So what is my solution in interval notation? It's negative infinity to infinity. Let that sink in, give it some thought, and hopefully we'll see another example like that in the packet in a minute. Number 3, solve the given absolute value equation, okay, not an inequality. Show your work, and then we'll do the same thing with an inequality. So absolute value of 7x minus 10 minus 2 equals 8. Add 2 to both sides. Absolute value of 7x minus 10 is equal to 10. Now we set up our two equations. Equations, not inequalities. One of them is 7x minus 10 could equal 10. The other is 7x minus 10 is equal to negative 10. Sorry, it's squashed. Add 10 to the other side. 7x can equal 20. X can equal 20 over 7. Add 10. 7x. I'm skipping steps right now just to make the video brief because you should have this done already. 0 divided by 7. 0 divided by 7 is 0. Done. Now, this was an equation. I didn't have to pull it from something like that where the word or was in the middle, so those are my answers. Now, how much will this change? If you really did all the work correctly, your work should get to a point where you have 7x minus 10, same sign, same number. So the same sign will be greater than, but it's not going to be 8. That number will be 10, okay? That's when I kept things the same. I got 10, right? So I had 8 plus 2. So 7x minus 10 is greater than 8. And the other one will be 7x minus 10 is less than negative 10. Please don't skip steps. I'm skipping them because you should have it done already, and you should just be using this to check your work. I'm going to add the 10, I get 18, and divide by 7, I get, x is greater than 18 over 7. Add the 10, 7x less than 0, x less than 0. So we have two tick marks here. Here is 18 over, oh boy, a little squash, 7 right there, and that's 0. They're both open circles. I'm greater than 18 sevenths, and I am less than 0. So what will our interval notation be? Negative infinity until 0, union 18 over 7, comma, infinity. So a little squashed, I apologize. Here's my interval notation. This and this make up my inequality, and this guy right over here is my number line. Next, we have another absolute value inequality. Again, you're not allowed to do this. Okay, I keep telling you in class not to. I'm doing it because your work is done. You're just using it to check. Absolute value of 9b plus 8 is going to flip less than 9. Now, that means 9b plus 8, same, and 9b plus 8, change. Subtract 8, 9b is less than 1. Subtract 8, 9b is greater than negative 17. Divide by 9, b is less than 1/9. Divide by 9, b is greater than negative 17 over 9. So I have this situation right over here. Absolute values are very finicky. You won't run into any of this situation here where it ends up being everything, because the positives and negatives have like a symmetry over a certain line. Okay, so the midpoint of these two things is going to be that symmetry line. So it's either shaded in on both sides of that symmetry line or shaded out. Okay, it's not going to ever end up being the whole line. Which number is smaller? Negative 17 over 9. Larger number is positive 1 over 9. Open, less than 1/9, but greater than that, so I'm in the middle. Interval notation, negative 17 over 9, comma, 1 over 9 with parentheses. Sorry, the orange is a little hard to see. Next, I'm going to get x alone in the middle here. I'm going to subtract 9 from all three places. I get negative 12 greater than or equal negative 6x greater than negative 54. Divide by negative 6. 2 less than or equal x less than 9. Number line. This will be 9 and 2. Closed. Open. X is less than 9, but greater than or equal to 2. So I'm between them right over there. Interval notation is 2, 9. Done. Next we have another absolute value. Subtract 5. I get the absolute value of negative 9 and minus 1. Subtracted that 5, less than or equal to 45. Now, my two inequalities, negative 9 and minus 1. Same. Negative 9 and minus 1. Change. Add 1. Negative 9 and less than or equal to 46. Divide by negative 9 and is greater than or equal. Negative 9 divided in there, so I'm just going to have 46 over negative 9. So we usually put the negative in the numerator. There we go. Add 1. Negative 9n is greater than or equal to negative 44. Divide by negative 9, flip that inequality. I get 44 over 9. 44 is 4 times 11, which is 2 times 2 times 11. Definitely does not divide by 9. It doesn't reduce. And the 46 is 2 and 23, and neither of those reduce with the 9 either, okay? Number line. Negative 46 will be the smaller of the two. Positive 44 is larger. They're both over 9. Both are closed, so both are colored in. Greater than or equal to the negative 46, but less than or equal to the positive 44, so we're shaded in that middle. Bracket, negative 46 over 9, comma, 44 over 9, bracket. Sorry, it's not meter, but hopefully you're listening as well. Next. Negative 3 plus the absolute value of negative 4 plus x equals 3. Add that 3 over absolute value of negative 4 plus x is going to equal 6. So negative 4x, not negative 4x, sorry. Negative 4 plus x, take what's inside. Now it could equal to 6, or negative 4 plus x can equal negative 6. Add 4 over, x is 10. Add 4 over, x equals negative 2. So I get 2 answers. How do you know they're correct? You plug them back in and you show it works. But where do you plug them in? Not here, not here. You plug them into the original, whatever was typed or written on the paper, on the board, wherever you got a question from. Next, I have a compound inequality. I have the word or in the middle again. So it could be one or the other. So really anything goes. Anything that satisfies this is part of our solution set. And, well, I know it says or. Anything that satisfies this, because I want to satisfy this equation or inequality rather, or this one. Not both, not an and. So I'm going to subtract 10. 3a is greater than or equal to 18. Divide by 3. A is greater than or equal to 6. Or I'm going to subtract 10. Negative 5a is greater than or equal to 0. Divide by negative 5. I know it's going to be 0, but the negative flips our sign. So it's that or that. Number line. Here's 0. Here's 6. I can be greater than or equal to 6. Or, this is more of a traditional or question, I can be less than or equal to 0. So that is done right there. And our inequality is negative infinity until 0 with a bracket union, 6 until infinity. So here I have my number line if they ask for it, graph, right, solution interval notation. Some of them I say to do it without graphing to see how good you are at it. If you can't handle that yet, then obviously you can graph it, okay? It's homework, it's practice. I wasn't planning on collecting it, but, you know, one day in the future, maybe I will start collecting these things. Maybe actually, probably the next packet. Same idea as before. I'm going to solve this given absolute value equation. I'm going to add the 5. You're going to show your work. So negative 3a minus 9, 28. Set up my two equations. Negative 3a minus 9 is 28, and negative 3a minus 9 equals negative 28. Down here, how will that transcend? Negative 3a minus 9 is less than or equal to 28. Negative 3a minus 9 is greater than or equal to negative 28. Sorry, I blocked out for a second, like forgot what I was saying. Add the 9 in really all these cases. Negative 3a equals, if I add 9 to this, I get 37. Negative 3a less than or equal to 37. Divide by negative 3. A negative doesn't do anything with an equation, so a equals negative 37 over 3. But here it becomes a is greater than or equal to negative 37 thirds. Next, add the 9. I get negative 3a. If I add 9 equals negative 19. Divide by the negative. Doesn't affect it here. A equals 19 over 3. There's the answer to my equation, but my inequality, add the 9. Negative 3a is greater than or equal to negative 19. Divide by negative 3. I'm going to do some sign flipping. A is, did I flip it? Oh no, I'm doing the next step. Is less than or equal to positive 19 thirds because a negative over a negative is positive. So there's my inequalities now. Graph the solution set. Write the final solution in interval notation. Number line. Here we go. I have positive 19 over 3 and negative 37 over 3. I'm greater than or equal to this. I am less than or equal to that. That is my number line, which is negative 37 over 3, comma, 19 over 3, and they both have brackets. Number 10, if I divide by negative 3, I get absolute value of 8m plus 4 equals, I don't care what I get a negative number. Will the absolute value of something ever equal a negative number? Nope. So no solution. Watch out for little sneaky questions, okay? Reason things out. They sneak up on you sometimes. Next example. Next we have another compound inequality. Subtract 7, we get 0, less than or equal to negative 10v, less than or equal to, subtracted 7, this is 60. Divide by negative 10. 0 is greater than or equal, negative 10, okay? That was what we divided by. Everything's going to flip. V, greater than or equal to negative 6. On the number line, things are going to have to turn around. Negative 6 goes here, 0 goes here. They both have or equals, so they're colored in. V is less than or equal to 0, but greater than or equal to negative 6. So I am in the middle with my shaded region, and then my interval notation is negative 6, comma, 0, and they both have brackets. Okay, graph on a number line, yes. Next, another or. Be careful with those or statements. Don't let anything mess you up over there. So with this or question, different color pen maybe? With this or question, I'm going to solve them both. So I add 8. 7n is greater than or equal to 7d. Divide by 7, greater than or equal to 10. Or add 6. Negative n is greater than negative 8. Divide by negative 1. N is less than 8. So I can be greater than or equal to 10. That's colored in, closed, and we're going this way. Or I can be less than 8. So this is not colored in, that's not closed, it's an open point. And we're going that way. Graph the solution set on a number line. Sorry, I hope it's not cut off. So we go now interval notation. Negative infinity till 8, parenthesis, union, bracket, 10, infinity. Okay? Next, we have some fractions. Maybe you don't like dealing with fractions, but you can't avoid them for your whole life, okay? Here I have, I'm going to look at this as negative 2 over 3x plus 6 over 5 is greater than, now 3.2, you could call it 3 and 2/10. You could call it 32/10. 32 over 10 reduces to 16 over 5. I'd rather have everything with denominators. What's your least common denominator here? Well, I have 3's and I have 5's. Least common does not mean 3. It's 15, the smallest thing you could turn them all into. I'm going to multiply everything in my equation by 15. Keep in mind, though, in your brain, your little thought bubble, that 15 is 3 times 5, and that's where it came from. When I multiply, the 3's cross out. So really only the 5 multiplies. So I get negative 10, well, to the top, to the numerator. Negative 10x. Here, plus the 5's reduce. 6 times 3, I have 18. Greater than the 5's reduce. 16 times 3, 48. Subtract 18, negative 10x is greater than 30. Divide by negative 10, x is less than negative 3. There's 1. Now here, distribute negative 12x minus 4. Subtract the 45, less than or equal to 100, not 90. Negative 100, sorry. Not 90. I see mistakes with this all the time. I feel like people think the 5's cross out and they only do 40 and 50. You give 5 to this guy, it's 50 and 50, right? I'm subtracting, same sign. Your answer will both, something negative minus something will still be negative. Add 4, so I have negative 12. X is less than or equal to negative 96. Now, x is divided by negative 12. This will turn around, okay? Now, 96, 100 is 25 times 4, just like little tricks in case you don't know your times tables. This is 25 times 4, so if this is 4 away, this is 24 times 4. Negative and negative, they're going to reduce. So I'm going to have 24 times 4 is 96, but I'm dividing by 12. To reduce, you do not divide 12 into both of these things, just really one. Okay, 24 over 12 is 2, and 2 times 4 is 8. So x is greater than or equal to 8. Okay, some of you probably have that memorized, but always showing tricks. Now, this is an and inequality. And means I have to make this true and this true simultaneously. At the same time, they both have to be true. So here's negative 3. Here is 8. Greater than or equal to 8 would put me that way. Less than negative 3 would put me that way. Does anything make this and this work? No. If this was an or, we'd be fine, but it's and. So what do we write? No solution. Another sneaky. Okay, I'm not going to sneak these on you on a test or a quiz, really, to be honest. But that's not to say that an SAT or a college placement test or someone else won't. Does it happen sometimes? Yes, but I'm not going to go out of my way to, cover your test in these. Could there be one question on it? Sure. Will there be? I have no idea. Okay, I can't promise yes or no. Here's another or. So I'm going to add 9. 7x is less than or equal to 0, which means x is less than or equal to 0 when we divide. I'm going to subtract 1. 10x is greater than or equal to 10. Divide by 10, x is greater than or equal to 1. There's an or in the middle. Ors are a little easier. If anything, you get too much when you say or. Oh, I'll have this or that, and now you end up with everything. Oh, I need something that has these specifications. It's this, it's this, it's this, it's this, and it's this. It has to be all these things. Well, you might not pull up any results. Here I have 0. Here I have 1. They are both closed, less than or equal to 0, or greater than or equal to 1, this or that. So we're good. That's better than the last situation here. Interval notation is negative infinity till 0, bracket union 1, comma, infinity. And there we go. That's everything. I'm rushing, so hopefully I didn't make any silly mistakes for you guys. I'm just trying to get this done. So you can check stuff. So add 9, 6x is less than or equal to, I add 9 to negative 33, you could add 10 and then take 1 back. So negative 23, so negative 24. Okay, not negative 22, be careful, I see that mistake a lot. Divide by 6, x is less than or equal, we're not dividing by a negative. I don't touch it because of this negative, you do it because of that number. Less than or equal to negative 4, or subtract 4, 7x is greater than or equal to 56. Divide by 7, x is greater than or equal to 8. This or that. So number line, less than or equal to negative 4, we're right over here. Greater than or equal to 8, we're over here. Now, I didn't say that you had to use a number line. You really didn't have to, but it does help more. Negative infinity until negative 4. Sorry, I started reading the next question. Union 8 until infinity. Now, if you notice, this is the exact same example as up there, except the word in the middle is and. This and that. Pick a number that is less than or equal to negative 4 and greater than or equal to 8. Can you think of one? Me, neither. So what do we write? No solution. Okay? Now, what else do we have here? Number 16. Hopefully you have the hang of this. Hopefully you can really do a bunch of these on your own. I have b is greater than or equal to 2, or negative 8b, add 9, is greater than or equal to 80. So b is less than or equal to 10. This one is also a little bit of a doozy. Here's 2, colored in. I can be greater than or equal to 2, and then I can be less than or equal to 10. So again, like one of the examples earlier, this really means anything goes. If this were an and question, you would only keep the middle where they overlapped, but this is an or question. Okay? So solve, then write an absolute value inequality, which has the exact same solution set as the compound inequality provided above. So can you make up an absolute value inequality that has the same result as what we have above? How about the absolute value of x is greater than or equal to 0? Was that hard? Is there an x value you can't plug in here to make this true? Anything you plug in will make this true. Okay? Or you could say the absolute value of x is greater than negative 1. Of course it's greater than negative 1. It's positive, no matter what you plug in. Okay? Now, next. These are a bit of a challenge question. I could save them for another day. I will read them to you to kind of help clarify anything. So you misplaced your iPhone at school one day. Fortunately, a friend offers his phone, and you log in to find my iPhone, and you begin your search. Let D represent the distance between your phone and you, or your friend's phone, right? You walk in a straight line down a hallway. So you're walking, I don't know where I should squeeze this. Let me draw over here. Say this is the hallway. You're walking in a straight line down the hallway. As you're going down the hallway at a steady pace, the distance D between your hand where the phone is and your missing phone is decreasing. So maybe your phone is somewhere over here. Your distance as you walk is getting smaller, right? The distance D was steadily decreasing. And just as you began to feel confident that you were about to find your phone, the distance D began to steadily increase. I drew you a beautiful picture. Describe what happened, support with a sketch. Well, I gave you a head start, okay? You could add a little bit more detail to it, okay? Next, we have the smallest distance Now the smallest distance, where is that? Probably right over there, right? The smallest distance you were ever able to get between yourself and your phone was 5 feet. I mentioned earlier in the video that absolute value is distance. Okay, so you might want to think about that. Write an absolute value inequality to represent the distance d, so you have to use d instead of x, between you and your phone. So see if you can write an absolute value inequality about the distance between you and your phone. I'm not going to go through this answer right here. Maybe I will add this another day. And then this one, let x represent the height of all people in inches allowed to ride a new roller coaster at Six Flags. The sign posted in front of the entrance for the new roller coaster says, to ensure your safety, all riders must be at least 4'8" and less than 6'5". Now these phrases are actually really important. You have to be at least 4'8". Can you be 4'8"? Is that acceptable? I'm not going to tell you that. You have to think about it. And less than 6'5". Can you be 6'5"? Is that height acceptable? So think about that. Write a compound inequality. Compound inequality, you should know what those are. I've said the phrase a million times. To represent the heights of the people permitted to ride the roller coaster as described. So X will go in the middle. It's going to be a very baby compound inequality, okay? Then from there, now with this absolute value, it's going to be slightly off because of a detail in here. I didn't really think it through when I wrote it down. So your absolute value inequality, it's going to be a little wonky. It's going to be a little off, but that's okay. We'll have a discussion about it just because of the sign that you'll use. That's the only reason, okay? Including a point and not including another point. To represent the heights of people permitted to ride the roller coaster as described. So wish you all the best on these.